Greetings all ICSE students and who's ever watching this video. Students, today I will discuss with you the chapter that is sound. And you have known that in class 9 the introduction about the sound. Here in this class we shall cover the topics, that is reflection of sound waves and echoes, and then the characteristics of sound. So first of all, you need to understand what is sound, or what do you mean by the term sound. Basically, you have known it that sound is a form of energy and which produces us a sensation of hearing. If a body vibrates, then the sound is produced. So therefore, for the definition of sound, you may write down, it is the form of energy audible within the specific range of the frequency and is produced when a body vibrates. Now what is this, the specific range of frequency, that I will be teaching afterwards. And for the propagation of the sound wave, a material medium is required. Without medium, the sound wave cannot travel. Now what we need for a medium? What are requisites for medium? So number one, the medium must be elastic. You can see this, which is written on the screen. And it should have inertia, it should have minimal friction. So these are the conditions required for the medium. And there are two types of waves, as you know this before. One is electromagnetic wave and another is mechanical wave. Mechanical wave is also known as elastic wave. Now what is electromagnetic wave? The waves which do not require any medium for their propagation are known as electromagnetic wave. For example, light waves. Now what is mechanical wave? The waves which require the material medium for their propagation is known as elastic or mechanical wave. For example, sound wave. Do you know the speed of sound in the definite medium? The speed of sound in the medium air is the least, that is approximately 330 meter per second, whereas the speed of sound in the solid like steel is the most or maximum, that is 5000 to 5500 meter per second, and the speed of sound in the liquid like water is approximately 1400 to 1500 meter per second. Now there are two types of mechanical wave. One is transverse wave and another is longitudinal wave. Now what is transverse wave, what is longitudinal wave? Now see in this animated diagram. Now what is transverse wave? The definition is not needed for you, but you need to understand the meaning of the transverse wave and longitudinal wave. What is transverse wave? The medium particles vibrates normal to the direction of the propagation of wave, forming crest and trough, is known as transverse wave. You see, the first diagram is the transverse wave. Here the medium particles are vibrating perpendicular to the propagation of wave. See, now this will be the propagation of wave. This is the direction from left to right. Now the medium particles are vibrating in this manner. See the arrow. In this manner the medium particles are vibrating and they are forming crest and trough. Now what is crest and what is trough? The upward displacement of the wave particle is known as crest, whereas the downward displacement, this is known as trough. Now what is longitudinal wave? If the wave particles propagate along the direction of the propagation of the wave motion. Now see there in this diagram, second diagram, how the energy is transferred. Now the medium particles are moving along the direction of the propagation of wave. Now this is the direction of the propagation of wave, and the medium particles, they are vibrating along this direction. In this way they are vibrating, forming compressions and rarefactions are known as the longitudinal wave. See once again how the energy is transferred in the transverse wave and how the energy is transferred in the longitudinal wave for your concept. Next, I am discussing with you infrasonic, sonic and ultrasonic sound. Students, do you know what is the range of audibility or audible range of frequency? Just now, whenever I have given you the definition of sound, I told you the sound will be heard by a specific range of the frequency. Now see, all the body, when they are vibrating in the medium, we may not hear the sound from everybody, but if the body is vibrating with a specific range of the frequency, then only we will be able to hear the sound. Now what is the specific range of frequency? That is known as your range of audibility or audible sound. The sound of frequency from 20 Hz to 20,000 Hz is known as range of audibility. Now if the body is vibrating with this frequency, with from 20 to 20,000 Hz, then only we can hear the sound. This is known as the range of audibility. What is ultrasonic sound and what is infrasonic sound? The sound of frequency more than 20,000 Hz is known as ultrasonic sound, which is not heard by the normal human ear. The sound of frequency less than 20 Hz is known as infrasonic sound. Both this ultrasonic and the infrasonic sound is not audible for the human ear, but some of the animals like bats, dogs, dolphin, etc., they will be able to hear this, both the ultrasonic and infrasonic sound. Now let us discuss about the terms related to the sound wave. These are very, very important terms. You have been studying these terms from class 8 onwards, but still you need to understand and also remember. The first term is your amplitude. What is the meaning of amplitude? The maximum displacement of a wave particle on either sides of its mean position is known as amplitude, and the SI unit of amplitude is meter. Next, time period. The time taken by a wave particle to complete one vibration is known as time period. Means to complete one vibration means what? One entire to and fro motion. That is known as one complete vibration. That means the vibrating body has to go again, it has to come back. Then how much time is taken for this? This is called the time period of the wave, and the SI unit of time period is second. Frequency, it is the number of vibration completed by a wave particle in 1 second, which means that in 1 second how many number of complete vibration is taking place is known as the frequency. Suppose while our body is vibrating in 1 second, it is completely vibrating 5 times, means 5 times it is having to and fro motion. Then in that situation you will consider the frequency of that vibrating body is 5 Hz, since the SI unit of frequency is Hz. And here remember students, whenever you give the definitions of all these terms, amplitude, time period, frequency. So you have to mention one term, that is particles of the wave or wave particles. Next term is wavelength. It is the distance between consecutive particles of a wave which are in the same phase, and the SI unit of wavelength is meter, which is denoted by the symbol m, and the symbol of the wavelength is lambda. Or we can also consider that the distance between any two consecutive crests or any two consecutive trough is also known as wavelength, and also the distance between any two consecutive compressions and any two consecutive rarefactions is also known as the wavelength. But for the definition, you remember this definition. This is the definition of the wavelength. Next, wave velocity. You know the velocity. Velocity means what? Distance upon time. Distance covered by a body per unit time is known as the velocity. So in the case of the wave velocity, similar definition you can give. That is, the distance covered by the particle of a wave means what? That is wavelength. So now here also you can write this definition. It is the displacement of a wave per unit time, and the SI unit of the wave velocity is meter per second. Let us see how wavelength, wave velocity and frequency are related to each other. See this relation, V is equal to F lambda. Here V stands for wave velocity, F stands for frequency, and lambda stands for wavelength. So this is how the wavelength, wave velocity and frequency are related to each other. Now in this expression, you might be asked to solve the numerical. So whenever you will solve the numerical here, maybe the two things will be given, the value of the two quantity will be given, and we need to find, or you need to find, the value of the other quantity from this expression. And whenever you solve the numerical, make sure that all the quantities are in the same system, means same unit. If velocity is there in meter per second, means that is the SI unit. Therefore frequency has to be in SI unit, that is hertz, and wavelength has to be in SI unit, that is meter. Then you solve the numericals. Let us see the difference between light and sound wave. Now what are the difference between light wave and the sound wave? As you know that the light wave can travel in the vacuum. So these are your electromagnetic wave, whereas the sound wave cannot travel in the vacuum, and sound wave are the mechanical wave. Next, number 2 point, the speed of the light wave is 3 into 10 to the power 8 meter per second in the medium air, whereas the speed of the sound wave in the medium air is 330 meter per second. The light waves are transverse electromagnetic waves, whereas the sound waves are the longitudinal mechanical wave. Transverse wave means, just now I have discussed with you, that is the medium particles vibrate normal or perpendicular to the direction of the propagation of wave, forming crest and trough. So light wave are such type of waves. And sound wave, when sound wave is propagating in a medium, they propagate in the form of the longitudinal wave, means one layer of air would be compressed, again another layer of air would be rarefied. In this way the sound wave travels, and they move along the direction of the, or they vibrate along the direction of the propagation of wave. Therefore these are longitudinal wave. The wavelength of light waves are very, very small, whereas the wavelength of sound wave are more. So let us see what is echo. Before I start echo, let me explain you about reflection of sound. Like light, sound wave also reflected back into the same medium. Now when the sound wave is propagating in a medium and if any obstacle comes in its path, then it will be reflected, and this phenomenon of the sound wave is known as the reflection of the sound, or the returns back of the sound wave into the same medium after obstructed by a rigid obstacle is known as reflection of sound. And due to the reflection of sound we get the term that is known as echo. Now what is echo then? All the reflected sound are not known as echo, but all the echoes are the reflected sound. Now what is echo? The sound heard after reflection from a rigid obstacle such as hillside, wall of a tall building, a cliff, edge of a forest, etc. after the original sound has ceased is called echo. Now, what are the conditions for the formation of echo? Remember, can you say me for how much time, for how long sound remains in our persistence? Sound remains in the persistence that is of 0.1 second. So now see what are the conditions for the echo. There are three conditions which is written on the screen. You can see the minimum distance between the source of sound and the reflector should be 17 meter in the medium air. You must mention the medium air because different medium for the different medium the distance or the minimum distance will be different. As you know that the speed of sound in the different medium are the different. So due to that reason the minimum distance for the formation of echo in the water will be not 17 meter. It will be approximately 70 meter. But in the air it will be 17 meter. And number two, the size of the reflector must be large enough as compared to the wavelength of the sound wave. The size of the reflector should be big enough, otherwise the reflected sound will be not produced, will be not heard. And number three, the intensity of the sound should be loud enough such that the reflected sound reaching the ear is audible. If suppose you make a very faint sound and the sound will go hit the obstacle, again it will come back to you, then only you will hear the echo. Now if suppose the sound is not louder, then by the time the sound moves towards the reflector and it hits the reflector, again by the time it comes back it may not reach to the observer's ear. So therefore the intensity of the sound should be loud enough so that we will be able to hear echo. Let's see how to determine the speed of sound by the method of echo. Now children, here you remember when the echo will be produced, initially the sound will be produced, then the sound will go from the source to the reflector and it hits the reflector, again it come back to the observer. If the observer and the source happens to be the same body, then how much total distance is covered by the sound for the formation of echo? Can you say me? If the distance between the reflector and the source of sound is d, and I told you the observer happens to be there near the source of the sound, then while going time the sound covers a distance of d, again while coming back the sound again covers a distance of d. So therefore the total distance covered by the sound wave is equal to d plus d, that is equals to 2d. And now we know that the speed is equal to distance upon time. So here the speed of sound, that is b, is equal to total distance covered divided by total time taken. Now the total distance covered is 2d, since d is the distance between the source of sound and the reflector. Therefore, for the formation of the echo, the total distance travel is 2d. So therefore, B is equal to 2d upon T. And this expression is very important for you. You will be getting numerical from this expression in the ICSE examination. So you need to practice the numerical. So next I am discussing with you the uses of the echo. Now, what are the uses of echo? The echo is used by bats, dolphin and fishermen, and it is also used by sonar. Then it is also used by medical field. Now, how is it used by the bats, dolphin and fishermen? You know, the bat detect their obstacle by emitting the ultrasonic waves and hearing their echo. Now, how it is happening? Can you say me? You are knowing that the bat can fly during the night time. Now, how the bat is flying during night time without colliding with the obstacle? See, the reason is very simple. When the bat is flying during night time, what happens? It produces ultrasonic sound which we cannot hear, and the speed of this ultrasonic sound is more than that of the speed of the bat. So if any obstacle would be there just in front of the or in the direction of the motion of the bat, then what happen? This sound will go, this ultrasonic sound will go, hit that obstacle, again it comes back to bat, and bat come to know that there is an obstacle in the direction of its motion. So knowing the obstacle, bat immediately change the direction of its flight. So that is how the bat sense the obstacle present in front of it during its flight. And this process of detecting obstacle is known as sound ranging. Remember this. This is called as sound ranging. Next, dolphins. How dolphins they detect their enemies? They also detect the enemies in the same method, by emitting the ultrasonic waves and hearing their echo. They also detect their enemies. And whenever a trawler man or a fisherman catches the fish in the sea water, how do they catch the fish? A fisherman sends an ultrasonic wave or ultrasonic pulse from the source into the sea and receives the pulse or receives the ultrasonic sound reflected from the soul of the fish by a detector. Then they use the formula, that is V is equals to 2D by T, to know the distance between the trawler and the fish, or the distance between the fisherman and the fish. And here the speed of sound in the water is taken approximately 1400 meter per second. So in this way the fisherman even catch fishes in the sea water. Next use, the use of echo by sonar. You know what is the meaning of sonar? Sonar stands for sound navigation and ranging, and it is a device which is used to find the depth of the sea or the distance of the obstacle from the ship in the sea water. Next use, the use of echo in the medical field. In the medical field, echo method of ultrasonic wave is used for imaging the human organs such as liver, gallbladder, etc. And this process is known as ultrasonography. And also the echocardiography is used to obtain the image of the human heart. So these all are the uses of echo. So for you have to learn the definition of echo, the condition of echo, and also the formula, that is the expression of that speed of sound during the formation of echo, that is V is equals to 2D by T, and also the uses of echo. Now next topic, that is characteristics of the sound. Can you say me, two sounds can be distinguished from one another by three characteristic properties. What are these? Number one is the loudness, number two is pitch or shrillness, number three is quality or timbre. Now one by one I am discussing with you what is that. So first point is loudness. What do you mean by loudness? Loudness is that characteristic property by virtue of which a loud sound can be distinguished from a faint one, both having the same pitch and same quality. Maybe two sounds are emitting and both are having the same pitch and also same quality, but one may be louder, another may be fainter. And remember that the loudness of the sound depends on amplitude. Larger the amplitude, more louder is the sound. See, the sketch is drawn just near the side. In the first case, you see the displacement times case, this is. Here it is your small amplitude, and in the second sketch it is large amplitude. In the first case, this is small amplitude means what? Soft note or faint note, whereas in the second case this is large amplitude, means it is the loud note. So this all about your loudness. Let's see what are the other factors affecting the loudness of the sound. Loudness of the sound is directly proportional to the square of the amplitude. That is number one factor. Number two, it is inversely proportional to the distance from the source. If the distance increases from the source, then what happens to the loudness? It decreases. So it is inversely proportional to the distance from the source, and it depends on the surface area of the vibrating body. Now how does it depend on the surface area? If the surface area of the vibrating body is more, then the louder sound is produced. Say for example, you bring a pencil. Now you hit the tabletop on the pencil or by using the pencil. Then at the same time you hit one smaller area bodies, say one scale, with the help of the pencil. When you are hitting both these, one is table, another is what? The scale. But I am sure that the sound which will be heard from the table will be louder. Why? Because the surface area of the table is more than that of the scale. Next point, the loudness also depends on the density of the medium. If the density of the medium becomes more, then the sound becomes louder. And it is also depends on the presence of the resonant body near the vibrating body. If near a vibrating body a resonant body is present, then what happens? The loudness will increase. Now the unit of the loudness is phon, that is PHON. Remember, the level of the sound is expressed in the unit decibel. Next factor, that is pitch or shrillness. Now pitch is the characteristics of sound by which a shrill note can be distinguished from a flat note of the same loudness. Shrill note means what? Is an acute note, and flat note means is the grave note. So that means the acute note can be distinguished from a grave note. So that characteristic we say that is pitch. And pitch of the note or pitch of the sound depends on the frequency. More the frequency, more would be the pitch, and more would be the shriller. or shrillness increases. So generally we have known that the voice of a woman is shriller than that of a man. Now what is the reason behind that? The reason behind that is the sound emitted by an woman is or the frequency of the sound emitted by the woman voice is more than that of the man voice. The frequency of the sound emitted from the man voice is less. Therefore, the sound emitting will be grave or flat. But at the same time, the sound which is emitting from a girl or an woman is shriller. Now see there, the sketch is given. How can you compare two sounds? One is having a low frequency, another is having high frequency. Both are having the same loudness. Means both the wave, if you compare, the amplitude will be same. Therefore, it is having same loudness. But one would be shriller, another would be flat. Which one will be the shriller? Obviously, the first diagram is shriller because this is high frequency wave, whereas the second diagram is grave or flat. Why? Because it is low frequency wave. Alright, so therefore remember, the pitch of the sound depends on the frequency. More the frequency, more will be the pitch. Next point, that is quality or timbre. Quality of the sound is the characteristics which distinguish two sounds of the same loudness and same pitch but are emitted by two different instruments. Say for example, one sound is emitting out from violin and another sound is emitting out from any other musical instrument, say tabla. And when both the sounds are emitting out, if I ask you, can you distinguish two sounds? Obviously, you will distinguish both the sounds. Why? Because the pattern of the wave or the wave pattern of these two sounds will be never same. Since one is emitting out from violin and another is emitting out from tabla, the pattern of the wave or the wave form will be different. Therefore, the sound will be different from the quality or timbre. So this effect is known as your quality or timbre. And the quality of sound depends on the waveform. Just now I have told you waveform means what? The pattern of the wave or the wave pattern which is formed when a sound is produced. And also the quality of the musical sound depends on the number of subsidiary notes and their relative amplitudes present in it along with the principal note. Now see there, three sketches are drawn for you. One is given sine wave, another is given wave of the violin, another is given wave pattern of the piano. So this curve, the first curve which is written as sine wave, this is your wave pattern of a tuning fork, and such type of wave is known as pure note. Remember that this is known as pure note. This is the principal frequency, therefore it is known as the pure note, and the sound emitted from the tuning fork is considered to be pure note. Whereas the sound emitted from any other musical instrument, say violin or piano or any other musical instrument, they contains subsidiary notes along with the pure note or principal note. See there, violin, the wave pattern of the violin is therefore is not like a sine curve. It is some curve is there. Are you seeing this? Again see, the wave pattern of the piano is also not same as violin and not same as the tuning fork. This is different. So from this graph you understand that the sound or the pattern of the wave which is formed by the different musical instrument are different, and this wave pattern is the waveform, and the quality of sound depends on the waveform. Since the waveform is different for the different musical instrument, therefore they will be changed in their quality. I hope you understood the topic. So I am ending my topic now. Thank you.